Good morning, everyone. My name is Michael Croxton. I work at Canon Virginia. Yeah, that same Canon that makes all those cameras. And, 90% of the people that come and see us at the booth say, hey, I didn't know Canon did all this, because most people only see the cameras, the printers, and the copiers, and they don't know that we do injection molding and we do tool building for injection molding. So Canon Virginia was established in Virginia, obviously, in 1985. We are the technical headquarters for North and South America, and we're the manufacturing headquarters for all the Americas. With Canon, we've been building and producing our own parts for so long that we've generated this large knowledge base that we're trying to carry over to support our outside customers. So we offer our contract manufacturing, we offer injection molding, and we also offer tooling for injection molding. So with all this knowledge, we have the same problems that everyone else has, and we're trying to reduce process costs. Most cases, when people are looking at reducing process costs, the first two issues they look at is how many parts they can make per cycle and how fast can they make those parts. When you have tried to reduce your cycle time and you've gotten to every single tenth of a second and you've hit that wall where you can't reduce anymore and still make a quality part, we've gone through a different avenue. We looked at what can we do instead of just reducing process costs, what can we do differently? So Canon, we had a different solution. We looked at what happens if we turn the cooling time into production time? What happens if we took the cooling time and actually started producing another part? Because during cooling time, nothing is really going on except for screw recovery. So the machine is like taking a break, and it does it every single cycle. I'd like to introduce you to Canon's Shuttle system. It's a very simple concept, but it's a very powerful tool to reduce your cost. Depending on your process savings of 50% are achievable. And that's when most people are trying to reduce it 1%, 2%, and 3%. And being aggressive and trying to get to 5% process cost. With this system, we're able to see 50% process cost depending on your process. The system is very simple, but let me explain to you how it works. The shuttle system basically shuttles molds in and out of the press. So the machine is set up where the mold opens, mold closes, injection, pack, and holding is occurring. Once holding is complete, the machine is sitting idle. What we're doing is shuttling the mold out and letting cooling time occur outside the press. The second mold goes in, mold closes, injection, pack, hold. Once cooling starts, we shuttle it out. The part in mold A is now cured. It's done. We're able to open the mold, eject the part out, close the mold, injection, pack, hold. And this process repeated over and over again. So depending on your process, you're able to get 2 parts, 1 machine, 1 process. So instead of just molding 2 parts, what if you were to look at this in a total different concept? So what Canon did at the K Show in 2019, we come up with a concept to make an S-shaped pipe, but in a total different format. With the severe undercuts in the S-shaped pipe, traditional tooling is not a possibility. You're going to need either some crazy lost core, gas assist, or some crazy secondary operation to make this part. We were able to do this with 2 simple 2-plate molds with single injection, molded the part in halves, took a robot, pulled the halves out, put it in a second mold, and overmolded it. Very simple. But we were able to do this with just 2 simple 2-plate molds. Tooling cost, very minimum. Secondary operations, not necessary. And this we did just to show what the capabilities are for this system. So Canon developed this ROI spreadsheet. And we can send this spreadsheet out to anybody who has interest. And it's just a basic Excel sheet with inputs for cooling time, injection time, production rate, production cost, machine cost, your number of mold changes you have per month, your total production volume. And it will take this data and tell you what your current process cost is. It also tells you in a side-by-side comparison of what your cost would be with a shuttle system. We can send this form out and allow the molder to take and put their process in and see what the savings is with their process, because every molder has their own hurdles and their own restrictions, and they have to come up with scenarios of what they can do to reduce this cost. And this is just a tool for them to play with to see what is the best fit and if the shuttle system can save them money. Let's say you have two parts. They're the same part, same material, but you have to run two cavities or two molds to meet your production needs. You can't run any higher cavitation because your machine won't allow it. So you're stuck with the tools you have. So you take those tools, you can put them in this system, and you can run two parts at one cycle. But let's say if you have different parts, and the only thing they share is the material. One part will run at, we'll say, 45 seconds. The other part will run at 40 seconds. You can put both of those parts in the shuttle system and run them at 45 seconds. Now, that's not a true 2-for-1 scenario, but it's still a like 46% process reduction. That's still a huge number. Let's look at it at a total different perspective. Let's say you're molding a part, and most people have this problem where a feature on the part is causing you to run the cycle a certain way, either much longer or it's a hurdle. It's an issue that's limiting your process window. Let's say you're running a part that has a very thick cross-section in just one area. So if the part was a uniform wall thickness, you could run it very fast, and you would have uniform shrinkage, which allow you to give you a much bigger process window. With the shuttle system, what would happen if we were to take and make this part as a uniform wall thickness? We say we molded it in mold A, and we had a shape. We'll say it's a bowl with a very thick flange. We mold a uniform wall thickness in mold A. We then take the part and put it in mold B and overmold it by giving it the thicker flange. Now we're able to mold the part in two molds at the very fastest possible cycle, because now we're using a uniform wall. We all have issues with machine capacity. At least most of us does. Let's say you have 100 parts you're trying to run, and you're trying to run them in two machines. Mold changes become a big issue. Every time you stop the machine, you're not making money. But what would happen if you were to stop the machine, or what happens if you were to change the mold while the machine is running? So the shuttle system can be turned off. So machine production can be running here with mold A while you change the mold over here in mold B. That means you could hook up the water, hook up the electrical, preheat the mold, and have it all ready to go. When mold change in B is finished, you turn the system back on, it then starts running two molds. How many people here change molds in less than 2 minutes? How many people change molds in the time it takes to stop the machine and change the program and start again? With the shuttle system, this is a whole nother avenue that you can do and save you some cost. Thank you, everyone, for your time. My name is Michael Croxton. Thank you.